A census takes into account everyone, and then a sample is just a selection of those people or things. And you've got advantages and disadvantages. So census, completely accurate, but disadvantage, time consuming, expensive. You can't use a census if it destroys the item. So if you have to like cut an apple open to count how many seeds or something, you can't do it to all the apples. And it creates a lot of data. Advantage of a sample is cheap, quick, easy. Fewer people have to respond, less data, but might not be as accurate, and it might not be large enough. And so it's kind of like the advantages of the census kind of match up with the disadvantages of the sample. And so you can, if you can't remember one, you can always just flip it over for the other. Let's see this one. Sure. Individual units of a population known as sampling units. Okay, you can number them to form a sampling frame. Okay, let's try this one.
Okay. Is one reason they shouldn't test all the avocados in the delivery is well, they probably won't do
Say it again, sorry.
is one reason because if they start cutting up all the avocados, they probably can't sell them on or something like that after.
Yeah, that's right.
Okay.
And have a bit.
One way to improve that could actually just taking a higher just taking a high number of avocados, like 10, and then seeing if it's the same as if it's like 8 of them is. Or,
A higher number of avocados.
yeah.
Yeah. So sample more avocados. Yeah. And A would destroy all of the avocados. Avos. Okay. So testing all the avocados would mean that there were none left to sell, and then they could take a larger sample, for example, 10 avocados. It would give a better estimate. Great. Okay, exam question.
It wouldn't would it not be it probably would be sensible, wouldn't it? Because then they know if all them people are doing it. Or,
So I think so long as you support your claim, so you'd say sensible because what?
and because if they're taking everyone, then they'll have track of all their members if they do exercise or
Uh, yeah, it would be totally accurate. It's a 2 marker. We need one more. What else could you say for a census?
that.
Sports club with 713 members. It's members too outside of the club.
Do you think like give them a better relationship with their workers or something, with their members? Or something?
Let's see. So the advantage for a census is it should give a completely accurate result. Let's say the opposite then. So let's say not sensible. Why not?
because it's too precise.
Too what, sorry?
Precise.
Nothing wrong with being too precise. What are disadvantages of a census?
It's time consuming.
Yeah. Anything else? Why you wouldn't ask all 700 members?
You could probably just ask about like 10, and you probably get a similar percentage of people.
So you could say
A sample is suitable, yeah.
so a sample would give an what's called a result that is nearly as accurate. And you could say some of the other stuff like too expensive. Someone will have to do it. Create too much data. Okay, I think we've said enough there. B.
So I'm not allowed to say some sample, can I? Or
Yes, we kind of put it in A. So take a sample and give one advantage.
it'll be, and they won't take. It'll be cheap, and it'll like take. It won't take much time.
Exactly. So it's just kind of the opposite of the other one. So less time consuming. So less time consuming and less expensive. So the two of them kind of are the opposites of each other. Let's see what it says. Not sensible, too time consuming. Sensible will use all of the data and give an accurate result. Aha, so it would have been fine. That would have been 2 marks. You say sensible and then support it, or not sensible and support it. So I thought the first one wouldn't be enough, but it is, yeah. And then, so you see how you can give either answer so long as you support it. And then take a sample. The advantages are it is quicker and cheaper and less data to process afterwards. Grand. Any questions with that?
Sorry, no.
Alright, so let's try. Let's take a look at this one. What will be part B?
Okay, so he's only tested like 4 loaves, so it won't be like an accurate representation.
Yeah. And part C?
Could you just say test more loaves of bread, for example, test something?
Yeah. So small sample size, inaccurate representation of the total population. Taking a larger sample size, yeah, great. Let's see this one. What would be A for this one?
It'll just take too much time probably.
Yeah, any of those reasons. Okay, how about B?
Sampling units. So is that just like when you have like in meters like meters per second or something?
Don't think so. Let me go back. This one. Individual units of a population are known as sampling units. The size of a sample can affect the validity. The size of the sample depends on the accuracy needed. Generally, the larger the sample, the more accurate. If population is very varied, you need a larger sample. Different samples can lead to different conclusions. Individual units of a population are known as sampling units. Okay, so I think it's like men, boys, women, girls, that type of thing. And so, a local concept. No. Aha. So, what would be the sampling units for this one? What people think about the traffic flow in a particular town?
I'm not really sure what to say.
I think it might be drivers and non-drivers. So that's different. They have different, like some drivers, they think, oh, it's great, there's the cars move quickly, but the pedestrians think, oh, it's bad, that the cars move quick, they want them slow or something like that. And how about C?
So we need to put down two different sampling units for B.
I'm not sure. I'm going to just check the answer in a second.
Yeah.
So what would be C?
I'm guessing it'll be something like what's the disadvantage? It won't be as accurate.
Why not?
Because it's a sample.
What about sample? They use the electoral register, meaning people who are registered to vote.
Oh, they can't ask people like under 18 or something.
Yeah, so excludes under 18s, excludes people not registered to vote. I don't know how that works. If everyone has to register. Okay, let's see this. So the question B, identify the sampling units, the individual residents of the town. Okay, so just the people who live in the town. There you go. So the people who live in the town. I thought, this is just so obvious that it's like difficult to even. So I suppose if you don't live in the town, you wouldn't be asked. All right. And then the electoral register of voters does not include people who are ineligible to vote, under 18. Yeah, that's good. So any questions? So let's see. So this sampling units are just the people who are going to be asked, the individual residents of the town, the people who are affected. All right. Any questions there?
No.
Why, Bucky, why? Okay, let's see this one. I should take an example. That's going to be fine. 800 hours example. How about question B?
Okay. So, what could you say that's not correct for all of them?
Yeah. So you could say on average it's 800, or you could give like a range, like 750 to 850.
Yeah.
I think so long as you support it, and then I think that's okay. While the average is greater than 800, one of the bulbs lasted less than 800. So the claim is justified on average, but not on the basis that it refers to all bulbs. Okay, there you go. Population and samples. How is that?
I'll give it a tick, I think.
Okay. Let's see. Sampling. So random sampling. Everyone has an equal chance of being chosen. The sample should be representative of the population, and it removes any bias. So there's 3 methods of random sampling: simple, systematic, and stratified. So simple is just, lottery. Systematic is following some kind of a system. So every fifth person, every seventh person, something like that. And then stratified is based on some kind of demographic, like men, women, something like that. Okay, a simple random sample of size n. Everyone has a single chance. So this is lottery. Yeah, so everyone gets a number, raffle style. Take one number out. Okay, you're picked. Okay, how about this?
Okay. So if they just put like the members like 1 to 100, and they just put into like a raffle or something, and they take things out of a hat. Could that be or
Yeah. So, calculator. Down on my decimal point, I have random number and random integer. So if I press alpha, and then that random integer, I think I do 1 and then comma. Where is comma?
sorry? How did you get to that? Sorry.
It's alpha and decimal point. So you can see random number and random integer.
Oh yeah, yeah.
And then the comma I just saw a second ago. Yeah, it's shift right bracket. So 100 close bracket, and then you can just keep pressing equals, and it will give a different random number. And let me just check something. Between 1 and 3. Yeah, so it includes those two numbers. So I think the real kind of thing they're looking for is give each member a number.
Yep.
Produce a random number using a calculator. And then do this 12 times, and those are your 12 members.
Yeah.
How about part B?
So if you just say random number using a calculator, that's okay for them basically.
Yeah.
Um. So for lottery sample, would we literally just say like write down, I don't know, 100 numbers down, pull out 12 members?
Yep. Let's see. So allocate a number from 1 to 100 to each member of the yacht club. Use your calculator to generate 12 random numbers between 1 and 100. Go back to the original population and select the people corresponding to these numbers. Write all the names on identical cards and place them in a hat. Draw out 12 names. Aha, so that's the difference. So the difference for part B is you don't write a number, you just write their name on a piece of paper.
Yeah.
That's what that's getting at. Okay, any questions there? See, it's so simple that it's like you don't even know what to do. Let's see, systematic sampling. Yeah, you follow some kind of system. So if you wanted a sample of 20 and there's a population of 100, 100 divided by 20 is 5, and so you take every fifth person. So 1, 2, 3, 4 pick, 1, 2, 3, 4 pick, 1, 2, 3, 4 pick. In stratified sampling, you divide them up into strata, men and women, for example, and then a random sample is taken from each. So it's like their fraction times the total population. So if it was 1/3 men, 2/3 women, then and you had a sample size of 15, it would be 5 men, 10 women. 1/3 men, 2/3 women.
Yeah.
Okay, let's try this.
Okay. So I'm guessing systematic or oh wait, no, probably yes, stratified.
Mm-hmm.
Okay, and then explain how you could use this method. If he says, for example, that he's going to ask like 10% from each age range from 18 to 32, 33 to 47, 48 to 62, could you say that? Or
So, what is the total population?
um, is 300.
And so, how many in your sample would be between 18 and 32? How would you get that?
75. Oh, like the percentage?
Yeah, or fraction or whatever.
Just 75 over 300.
Yeah, so it is 75. He wants, but what's that? So the total population is 300. So he wants 75 out of 300. And what of what sample?
Stratified random sample.
What's the sample size?
Oh, so it's not 300.
300 is total population.
Is it 80?
Yes. And so he wants that fraction of 80. Oh, there you go. So it's 20. So 75 over 300 is the same as a quarter, I think.
Yeah.
Okay, how about next group?
Yeah. Oh, so I need to do for each age range. So would it be then 140 over? Yeah, over 300.
Mm-hmm.
So
What will that be?
that would be. Um, I might have written it wrong.
No, come on. 140 out of 300 times
I
80.
I got 112 over 3.
Okay, so let's round it to the nearest person. What would that be?
37.
Say 37 people. And then the last one?
Okay, and then I got 68 over 3.
Okay. And so what would you write for that one?
You'd round it, and then you'd get 23.
So, and that rounds to 23. And so what do our three estimates add up to? 20, 37, and 23.
Probably 80.
So 20, I think so, 37 and 23. So it works out. So 7 plus 3 is 10. So it'll work out, I think. And write down the name of the method of sampling the thing should use. Explain how he could use this method to select a sample of workers' opinions. So I think B was just kind of asking us in general, and we just actually did it. How he could do it would be that proportion of the population should be also that proportion of the sample. So if it's a quarter of the population, then they should be a quarter of the sample. So 80 workers, 20 in the thing. Let's take a look. So they did work it out. Great. They did the same thing. 20, roughly 37, roughly 23. Number of the workers in each age group. So that's what we had to say at the end. So then we have to actually give each of these a number, pick some random numbers, and go from there. Yes. So we might, even if we pick like 5 people randomly out of 80, we might not pick anyone in the 18 to 32 range.
Yeah.
But they were at least possible in the sample, and they were the same as the sample. So we had to say number the workers in each age group, use a random number to produce the required quantity of random numbers, give the question. Okay. Any questions about that one?
No.
Okay. Let us see. So now it's advantages and disadvantages for these three. And again, advantages of one usually match up with disadvantages of the other. So simple random sampling. There's no bias. Quick, easy, cheap. And everyone has equal chance of being picked. Simple random sampling isn't suitable when the population is large and a sampling frame is needed. So you need some kind of census or, a list of everyone. So systematic sampling is quick and easy and it's suitable for large populations, but you need a sampling frame and it can introduce bias if the frame is not random. So if you picked every fifth person, but if every fifth person on your list was a man, then it would be nothing but men, something like that.
Yeah.
Stratified sampling. It accurately reflects the population and it guarantees proportional representation. So a quarter of the population is men, so a quarter of the sample is men. So that's an advantage. The population must be clearly classified into different groups. Selection within each stratum suffers from the same disadvantage as a simple random sampling. Okay. There you go. Okay. Exam question. How about this?
No, should I say something like there will be no bias?
Mm-hmm.
And, uh,
Two marker. You need to say something else.
um,
Take a guess. Think back to the other stuff we were doing earlier. So simple random sampling is just, lottery or whatever, random number.
yeah, it won't take much time.
Yep. Quick, cheap, easy, We were doing stratified sampling a second ago and we had to put like fractions times stuff into our calculator. Lottery, you don't do any of that. Okay. B.
Would you just say that there's that you'll most likely get more girls' opinions than boys?
So using simple random sampling. Yes. So it might be biased towards girls.
Yeah.
And so let me just think. The sample might not represent the population. Yeah. Okay, and see.
So size 40. So would I say something like 40 times something over uh, what's it, about 300 equals to something.
So let's just actually do it. So how can we? So there's 75 boys, 125 girls. We want a sample of 40. So in the sample, how many boys, how many girls?
So 75. Oh, right. Of size 40. So 20 boys, 20 girls. It won't be like that, will it? Would it?
It'd be what, sorry?
Would you just do 20 boys, 20 girls?
No, that would be if it was like 100 boys, 100 girls. Then it would be 20 of each. But there are fewer boys than girls, so you wanted the same proportion.
So would you have to like do 125 over 300 times 100 to find out? Oh no, not 300, 200. Sorry, to find out how many girls you need to ask.
It's 125 out of 200,
Yeah,
and then that times what?
100.
No, 40.
Yeah.
And then how about boys?
So says the answer's 15.
So 15 boys and 25 girls.
Yeah.
So another way to think of it is for that one, 75 is to 125. So that is 3 is to 5.
Yep.
And so 3/8 are boys and 5/8 are girls, basically. So let's do this in general. So what would you call? So this is like boys over total, I'll call it total times sample. And so a better way would be like boys over population times sample size. And that will give you how many boys should be in the sample, and then you do the same for girls. Yes. Okay, let's check. And then we would have to say, so what would you do once you have that? So you've picked 15. So you know your sample should have 15 boys and 25 girls. How would you then pick them to be in your sample? Like which 15 boys?
Would you? Is that when you'd like just do 15 random boys from the 75?
I believe so. So let's take a look. The teacher should divide the sample size into the same proportion as the population and then randomly select the 15 boys and 25 girls. Great. The simple random sample. So B, the simple random sample may not reflect the proportion of the boys and girls. Yes. So because you might take a simple random sample and end up with 20 boys, 20 girls, but actually that's not really proportional to the school. And then what was the other one was the 2 advantages of simple random sampling: easy, cheap. Each pupil has a known and equal chance of being selected. Okay, any questions there?
No. No.
Okay, let's see this one. Yep. Okay, how about this one?
Okay. So would you? And each has. Or would you have to just split it up three, like 700 divided by two, or
700 divided by what, sorry?
by two?
Why is it 2?
I'm just assuming there'll be like half male, half female, or something.
So they, nope. The important word here is systematic. So this is a different thing.
So every fifth person. Does that mean that I need to do 700 divided by 5?
Yeah.
And then that'll be 140. Oh no, sorry. 20.
Okay, and so how would you get a sample of 20? Sorry, how would you get a sample of 35?
Did you do 20 over 700 times 35?
So you're thinking of stratified. You would take every 20th person.
Every 20th person, okay. Right. Yeah.
So that's the system that you follow. So systematic, that's the system. And B.
There's a minor chance it can be biased or something like
It is known that the management team all have employee numbers ending in 0. Yes, it's might create a biased sample. Biased sample towards more, like towards over representing managers in the sample. And that's because if you're taking every 20th, so every number in your sample will end in a 0 as well. So 20, 40, 60, 80. And so,
that.
I believe so. So generate the number of the first employee to be chosen randomly, and then select every 20th employee from the ordered list of employee numbers. So they take the first person randomly. So they don't start from person 0 or person 1. They pick the first one randomly. So you might start from person 37 or 111, and then just every 20th after that. So 131, 151, something like that. The sampling frame is not random, so the sampling method can introduce bias. For example, if the first person chose an ending in 0, then all the employees will end in 0. Yeah, and it'll just be managers. So systematic sampling is some kind of sample like this. So total divided by sample size, and then every one of those. Any questions about that?
No.
Let us see. This one. Okay, how about this one?
Okay, so would you have to do the calculator thing?
Yep. So a simple random sample of size 50. Yeah, so give each of them a number. Select 50 random numbers, and then go back to the list and then choose those ones. And how about B?
Could you say that the school could use like a stratified one, and then can you like separate stratified sampling based on age?
Yes.
Maybe
So
7 year or 8 or something like that.
yeah, stratified sampling. Anything else other than age?
Boys to girls.
Yeah. And you could do it based on that. Yep. So stratified sampling. Divide the sample into the same proportion as the proportion of students in each year, possibly split male and female too, and choose the required number of students randomly from each individual group. So basically do stratified sampling. Great. Number of students. Yeah, and then that one. Oh, did we say the disadvantages for A? State one disadvantage of the top one.
You say results may not be as accurate.
I'd say the sample may not represent the population. Like you might just by chance get only boys or only year 12s or something like that. The population is fairly large and it might not be representative of the different age year groups of the pupils. Yeah. Okay, sampling. What do you give yourself there?
I think I'll give it like 3/4. I think I'm sort of getting there.
Yeah. Okay, non-random sampling. So quota sampling and opportunity sampling. So quota sampling is when you have to meet some kind of quota, like you need at least this many men, at least this many women, something like that. So like our stratified thing, yeah. divided into groups, each one with characteristics. Enter you would meet people, assess their group, and then allocate the appropriate quota. And then you stop once the quota has been filled. Yeah, and then opportunity sampling is like based on opportunity. So like the first 20 people outside the supermarket Monday morning.
Yeah.
So something like that. Okay, so advantages and disadvantages. So quota sampling. A small sample can still be representative of the total population. No sampling frame needed. Quick, easy, cheap. Allows for easy comparison between different groups. So you could say boys shop buy this stuff, but girls buy this different stuff. Disadvantages. It can be biased. Must be divided into groups. Increases the scope of the study. So, okay, it can be expensive. That stuff, if it's bigger. Non-responses are not recorded. Yeah, so if someone says no, I don't want to do this study, then they just kind of ignore it. But that could be a big reason for it. So opportunity sampling, easy to carry out, cheap. Disadvantages, it's unlikely to provide a representative sample, and it's highly dependent on the individual researcher. Let's try this one. Okay.
So if it was opportunity sample, would that just be if he picked like the five shortest people and at the bottom of the group?
So I think not the 5 shortest people, but I think picked maybe the first 5 who come into practice or something.
Yeah.
Who enter the gym or whatever, the court. Okay, that's my guess. B.
By chance they could all just be like five tall people, five of the tallest people walking in or something.
Yeah. So the might create a sample that is unrepresentative of the total population, and C.
Um, so would you say something like quota sampling? I'm guessing.
Quota sampling. So they want that's 2 marker. So explain how the coach can take this sample.
What was quota sampling again? Sorry.
So you have to meet some kind of quota, like 5 girls, 10 boys, something like that.
Not sure.
Not sure either. Maybe it's take a certain number of students from each height group or something.
Yeah.
Like the kind of from the tallest, from the shortest, something like that. Okay, So opportunity sampling. The first 5 who enter the court. So you said first 5 on the list. So they said first 5 on the list as well. The problem. So B state 1 disadvantages. Yeah. So the disadvantage of that is these will be the 5 shortest players, because it was ordered from smallest to biggest, I think, and so it's not representative of the whole team. And then C was take a simple random sample by generating 5 numbers and selecting these players from the numbered ordered list. Okay, simple random sampling. There you go. So, and I think whatever you say, so long as you support it with a valid reason.
Yeah.
Simple random sampling is fine. I was thinking as well. You don't have to use quota for that one. Let's see. Researcher. Okay, how about this?
So the sampling method is opportunity.
Mm-hmm.
Well, and it's probably going to be like unlikely to be reliable.
Mm-hmm. Why is that?
First of all, people kind of cinema could all just be like children, so it might be different to like if an adult was walking out or something.
Yeah. So the sample will be unrepresentative of total population. Like maybe 4 friends, coming out. Okay. B.
So do I have to suggest a method and then give 2 ways or something?
Yeah.
Did I say something like random sampling?
Well. Okay. If you're doing random sampling based on what? So you want the number of hours of television watched by people in a local village.
People in a local village. It's just simple. To improve the method, so for example, they could have gone to people that living in the houses, for example, rather than just in the cinema.
Okay. So go to which people, which houses. Like, how would you know?
Would you find out which houses in the town have in the village have TVs, and if they do, go and
Okay, so I think that would be a census.
yeah,
So census, ask everyone in the village.
yeah.
Village. That's one way to improve it, I think. One more.
Um,
Any different way you could do it?
could you do like uh a demographic or something like a stratified?
So take a stratified sample. Stratified sample, and ask them. Yeah, so like young, old, male, female, that type of thing. Let's see. So we said opportunity sampling. It's unreliable because it might be given unrepresentative thing. Opportunity sampling. The data is unlikely to be representative since the researcher asks a very small sample in a very specific location. Then you could say take a larger sample. You could also vary the time of day and vary the day that you ask and vary the location where you ask. Okay. So that would be still using opportunity sampling, but just change the day, change the time. So ask more people, change the location. So like coming out of a supermarket or something. There you go. And again, lots of different answers you can give so long as you can support it. Any questions there?
No.
Okay, what is this one? Yeah, okay, how about part A?
Would you just do like 150 um, over 350 times 70?
Mm-hmm. So 150 over 350 times 70. Okay, so that gives 30. And so the female?
And so the female would be. The female is 40.
Yeah. And how do they take? Okay, how about B?
Um, let's stratify something. Um, would it be the quotas like numerical and stratified as like based on like things like men and like gender and stuff like that?
I think in quota, um, in quota sampling, non-responses don't count.
Okay.
And so you have to just keep going until you get 30 men and 40 women.
Cool.
Non-responses are ignored. So if someone says, no, I don't want to take your survey, and just keeps walking out of the supermarket or whatever, the person just stays there until they get 30 men, 40 women. Okay. Let's check. So we divide the sample into proportion, 30 male, 40 women, and we assign as K. In a stratified sample, the people selected in each group will be generated randomly. In a quota sample, they will be the first people. Aha, so they're not generated randomly for quota. It's literally just the first 30 men, the first 40 women. So one advantage of quota sampling.
One advantage of quota sampling. Uh, is that I don't know. It's cheap.
Let's see. It's over stratified. Is it cheaper? So the difference is that quota sampling, they just take the first 30, like first N people. So let's say, I wouldn't say cheaper. So instead of taking 30 random from the population, you would just take the first 30. I suppose it is cheaper. I'd say there's something else to it.
Could you say that? Oh, could you say the quota probably has like a better representation of the population as a whole because they're not like simplifying it down?
I'd probably just say it's quicker.
Okay.
So if instead of taking randomly, you just take quicker. Let me check. Do I even have it? Oh, did I cut off that answer? Hopefully I didn't. No, I don't have it. Okay, and then what is D?
Okay. So essentially, criticise quota sampling.
Um, this might not be quota sampling. Is this opportunity sampling for D? Stands at the entrance. So he wants to investigate the types of car people own.
Oh no, sorry. It's at the bottom. Yeah, it says the researcher stands at the entrance to this.
Yeah. For each
Um, could you say like, the car that like one female or male has doesn't represent the entire population?
So yeah, and so that's basically opportunity sampling. And so you would just say the disadvantages of opportunity sampling. So like same with the cinema one. Sample maybe unrepresentative. So maybe there's a yoga class going on at the gym in a few minutes, and so it's all women who are leaving, or mostly women who are leaving. The housing estate, maybe lots of rich people live there, lots of poor people live there, so it creates a bad sample.
Yeah.
Maybe unrepresentative of population. Okay, let's just see. So non-random sampling. What do you give yourself there?
Yeah, probably just like 75%.
Okay, so that stuff is what you'll use for statistics. Let's just see. So census is everyone, and then sample is So advantages, census has everyone. Sample might not be representative. Destroying all the stuff, yes. Anyway, so I think you're okay for this stuff. We're back to the good old days of doing about half of a chapter in one lesson,
Yeah.
instead of crazy exponential stuff. After this, let's see what type of data and then large data set. Yeah. How was that for you, Andrey?
Yeah, I was good, thank you.
And so I feel like we can finish this next time and then move on.
Yeah. Yeah.
Great. Any questions for me in general?
No, I don't think.
All right. Well done, Andrey. You did great. I look forward to chatting again next time.
All right, cheers. Thanks.
Have a good one. Goodbye.